Okay. So I will just quickly revise this because then it will not come in the recording. So we started our lecture with the fact that why the research is possible because the nature follows the rules. And in the research, what we do, we try to find these rules and express to the world. That is the research. Okay. So convenient way to express the rules of the nature is mathematics. So don't have the fear about the mathematics, but learn the tools that can help you to process the data. So today we'll see the Microsoft Excel to find the relationship between the data. So we started with the data processing. In the data processing, we edit the data. Edit the data means we locate the errors. Then we reject the data, correct the data. We use the Chaunes criteria to reject the doubtful readings. Then we do the coding. In the coding, what we do, we assign some numbers. Like we assign some numbers, like for the pass, we assign the 1. We assign the 0 to the fail. Okay, then comes classification. In the classification, we make the groups so that the analysis is easy. That is called as classification. Now we'll move further. That is the tabulation. We summarize the raw data and we try to display that in the form, on the compact form. Okay. So if the data is too large, better split in the different sheets. Okay. So that will be better for you. Now you have collected the data. Now comes the data analysis. Please understand. Okay. So when I told you that in the research we want to find the rules. Rules are generally what? The relationships. Rules are what? Relationship between different parameters. Okay. So I will just give one example here. Just pointer out. Suppose your weight of the weight of a person is proportional to what? Age. Suppose the if you see the newborn child, okay, 1 year it will have particular weight, okay. 2 years it will have particular weight, okay. So as the age increases, weight of the person increases, okay. So these are the two parameters, age of the person and then weight of the person, okay. Now we'll see what are the different data analysis. One is correlational analysis. In the correlational analysis, here there is a variation of 2 or more variables for determining the amount of correlation between these variables. Okay, so correlation analysis is very important in case of social and business researchers. Then comes causal analysis. In the causal analysis, what we do, we study how one or more variable affect the changes in the another variable. So what we do, we vary one or two variable and we see the effect of that variation on the other parameters. That is the causal analysis. So it is a functional, you can say study of functional relationship between the two or more variable. This analysis is a regression analysis, and that today's topic, that is a regression analysis. So we vary the one parameter Then we'll see the effect on the another parameter. Okay. We'll move further. I will just delete this. Where is that? Yes. Clear all. So I will move further. Are you clear now? I have discussed 3 points. First point, that nature follows the rules, and that is the basis for our research. Why we spend so much money on research? Why we study? If the nature is not following the rules, no need of studying the engineering, science, or we can say medical sciences. Okay. This is only possible, study is only possible because nature follows the rule. The next step was what? We can express these rules in the mathematical, we can express in a convenient way in the mathematical form these rules. Okay. So that is the need of the mathematics for researchers. Okay. Now, when we find the rules, we need to collect the data. Okay. We need to collect the data, and based on the relation between the data, we have to find the rule. Okay. Now we'll see the causal analysis. In the causal analysis, what we do, we vary one parameter, one or two parameter, and see its effect on the another parameter. Okay. Now we'll move to the what is called as a regression analysis. So if you are aware, I just mentioned you, the mathematics is a very important for the research, because it is a way we can express the nature's rule in the mathematical form. Okay. Now you might have learned in the 10th, maybe in 10th, the equation of line. Can anyone remember equation of line? Maybe even engineering, science, they have learned at a higher level. For all, you can say all the PhD students, they might have learned equation of line. Can anyone tell me what is the equation of line? Yes, from
Y is
audience.
equal to M
Yeah. Yeah. Y is equals to mx plus c. Okay. So
C.
generally, yeah. When we learn in the 10th, we learn as mx plus c. So I just write, instead of m, I am writing a. Instead of c, I am writing the b. Okay. Where m is the slope, c is a y-intercept. You can see here, c means what? B. E is what? Y-intercept. Okay. Where the line crosses the y-axis, that much distance is what? C. Okay. And the slope is what? If you draw the triangle here, if you measure this distance, dy, if you measure the distance, dx, then you can write slope. What is that? Dy by dx. Please don't bother if you're not from mathematical background. Don't worry. I am just telling the background. Then what we'll do, we'll use the Microsoft Excel, where you'll not need much mathematics. Okay. Okay. In this way, this is the way this is the equation. Okay. What is the form of this equation? At any point, any x, at any x, suppose I get this x. If I put the value of x here, I know here value of m is known. Okay. Once I find this equation, value of m and c is known. Okay. So suppose, just for example, value of m is 1.5 and value of c, suppose value of c is 5. for any value of x, if you just put the value of x here, suppose the value of x is here 2. What I am getting? Just you put the value of x, I am getting the value of y for that x. Please understand. That is the fun of this equation. Once the equation we get, we just put the value of x. Like as similarly, find suppose that y this equation is of the weight of the person. Suppose this equation is of weight of the person. Suppose y is the weight of the person and x is your what? Age. Once you put the value of age, you will get what? Weight of that person. Please understand it. Okay. Okay. So once the equation is formed, it is what? Compact representation of data. Can anyone repeat? Once the equation is formed, what is that? Equation is what? Compact form of the data. Okay. It represents so much data. Okay. When I will give you the example of when we form the equation. For example, I'm giving just 4-5 data. Okay. Data points. But for in reality, when we form the equation, we'll take very huge data, okay? So that the equation will be more realistic. Are you getting, can anyone repeat? What is the equation? Equation is compact form of what? Data. Can anyone repeat? Yes. What is the equation is now? Equation is
Compact form of data.
yeah, compact form of data. What happens in India, the people tell to remember the equation and then students find it difficult, okay? Not every equation we need to remember, okay? Only important equation we need to remember, okay? So when the equation becomes big, better that student should read it from the paper. So you have to give in the question paper, okay? Same way, okay? So equation is compact form of the data, okay? So need not to preserve all data, only the equation is enough, okay? So our topic was linear equation. So this is the equation, okay? So what it represents? It represents the straight line, okay? So if you see the straight line, so what is that? It is the locus of the points, okay? So it is not the continuous line, but is made up of what? So many points. There are so many points. If you put so many points very close to each other, what happens? We get the line. Okay, we get the line, and this line is what? Straight. Okay, that is the straight. So as a scientist, we are very much want that the relation between the two parameters, if it is a linear, it is good. But seldom it happens, rarely it happens that relation between the two parameters is linear, okay? But the same concept, linear concept is used for forming the other relations, okay? So the basis is same, okay? Basis is the linear equation, okay? Now we'll move further. Are you comfortable with the equation y is equals to ax plus b, or you can say y is equals to mx plus c, okay? So I will use y is equals to ax plus b, okay? Okay. Now we have the data, okay? We have the data. I'll just switch on the marker. You can see the data points. You can see here data. You can see the data point here. You can see data point here. We see data points. Okay. But now from this scattered data, please, line is not there. Please remember here now, only there are the 4 points are there. Okay. What are there? Only 4 points. Now I have to find the straight line. Okay. Please understand, these points are little scattered because our measurement systems are not, we can say, 100% accurate. There is always error in the measurement. Because of that, the data is scattered. Okay. Now, so many datas are there. Okay. You can see, I have only plotted here for simplicity 4 points, but so many datas are there. From that, we have to find the relationship. From that data, we have to find the relationship. Okay. So if I write y is equals to ax plus b, okay, that will be the function. Okay. That will be the function. Okay. That will be the function. Okay. So I will try to find, okay. I want to find the straight line from the data. So first of all, I will find what is called as deviation. What I will find? Deviation. Just a minute. Yeah, deviation. Okay. What I will find? Deviation. Okay. Deviation is what? Actual y distance. Okay. Suppose this is your point. Okay. Where is our point? This is our point. Okay. Actual point is this, which is having the x1 coordinate, y1 coordinate. Okay. And what is this? This point, you can see the line on the line, straight line. It is what? F of x1. It is obtained from the what? Equation. This is obtained from what? Equation. Please understand. So this gap, actual measure value and the point on the line, the difference between the actual point and on the point on the line. Line is what we are predicting. Line is what we are predicting. Okay. So that difference is called as what? Deviation. Okay. The difference is called as deviation. So what we want to do through the analysis, that this deviation, the gap between the actual point and the line should be minimum. What we want in the analysis, that this deviation should be minimum, so that our data are more close to the line to be predicted. Line to be predicted. Okay. So that difference is called as what? Actual y minus predicted by the equation. That difference is called as what? Deviation. That difference is called as what? Deviation. So we'll move further. Okay. From the deviation, we'll try to find something better. Now, we will move to the mathematics. Okay. Suppose I want to minimize this deviation. So if I try to minimize this deviation, there can be any n number of solutions. There will not be single solution. Okay. There will be n number of solutions. Then next option is, instead of minimizing the deviation, what we do, we minimize the square of deviation. We minimize what? Sum of the square of deviation. We minimize what? Sum of the square of deviation. If you do this, if you minimize sum of square of deviation, if you minimize sum of square of deviation, then we get what? Only single solution. Then cannot be n number of solutions. So if you find manually, if you find with the software, if you minimize the sum of square of deviation, then we'll get only single solution. Okay. So what you do now? We sum the square of deviation. Okay. And thereafter what we have to do is, we have to take the derivative. We have to what? We have to minimize. What we have to minimize? we have to minimize the derivative. Okay, so we'll just move further. So we have to minimize what? The sum of the square of the deviation. So we use one mathematical concept. Here we use one mathematical concept. What? If you take the derivative, okay, at maxima and minima, what happens to the derivative? Can anyone tell? I will just draw the curve here. Whether it is maxima or minima, what happens here? Maxima and minima. What happens to the derivative? If you draw like this, can anyone tell what happens to maxima and minima in case of curve? Okay, can anyone tell us what happens maxima and minima? What happens to the derivative? Yeah.
Is it 0? I'm guessing. I've long
Yeah.
forgotten my
It
mathematics.
is zero.
Probably 0.
It is very simple. Just I told you, na. Like if it is a y here, it is a x here. Now this
Yes.
line becomes what? Horizontal.
parallel,
Means
so, yeah.
parallel means what happened? Change of y will be what? 0. dy by
0.
dx will
Yeah.
be 0. So the slope is 0. So what we'll do? We'll take the derivative of error with respect to, there are two parameters a and b constant. So we'll take the derivative of error with respect to a and put it equals to what? 0. Same thing. We'll take derivative of error with respect to b and put it is equals to 0. So it will be either condition of maxima or minima. Okay. So we'll assume that it is a maxima. Okay. We'll assume it as a maxima. Once you put these values, you will get some solution. You will get some equations. You will get some equations. Okay. So you put and then we'll get some equation. That equation, we get the equation, solve this equation. Okay. So we get this equation. Like in our PG student from mechanical, they need to remember this equation. Okay. So what is that equation is? A into sum of the square of x plus b into sum of the x is equals to sum of what? X into y. Next equation is a into what? Summation of all x data plus b, and n is number of data, is equal to summation of y. Okay. So here we get the two equation. These two equations are what? Linear equation. Okay. This linear equation we can solve easily. Okay. Or we can also solve this linear equation with the help of what? Calculator. Okay. Now it is possible with the calculator. It is possible with the calculator. Okay. To solve. Got the idea? We'll get the two linear equation. Then you need to solve it. And once you solve, then we'll get what? Value of a and b. What you will get? Value of the a and b. Once value of a and b you got the equation y is equals to ax plus b. Okay. Once you get the value of a and b, that is you got the equation. You got the equation. Please understand. Now you just put the value of x, you will get the value of y. Understood? All of you? Understood? We need to only put the value of. So why we did so much exercise? This is the equation. Here just you add all x square. Here you add all x. Here you add x into y. Here you add x. Here you add y. Then you will get this equation. And if you solve this equation, you will get the value of a and b. Once you got the value of a and b, we got the equation. Okay. So why this exercise is to find the value of A and B. Understood? Now we got the equation. Only you just put the value of X, you will get the value of Y. Understood? So this method is called as least square method regression analysis. So here we find the relationship between X and Y, and then ultimately we find the relation Y is equals to AX plus B. We go get then, once we put the data in Excel, we get the value of A and B. Then the equation is in terms of, I will give just one example, maybe 5x plus something 3.2, like this equation you will get. Okay. Got the idea? Now we have to use the Excel. I have, I think, shared the Excel sheet, whether you got or not. Got the Excel sheet? Yes. You got the Excel sheet? I sent you one Excel sheet.
No,
Yeah.
sir.
No. So what I will do, I will share through this Zoom meeting. Okay. Now we just learn very simple relationship which rarely occurs. Please understand here. We will be very happy if the relation is linear, but this seldom happens, and relation can be anything. Okay, maybe exponential, maybe logarithmic. Okay, so this is the first. Now, once we in Excel, we can see the data points, actual data points, as well as the line fitted. Please understand. Okay, both the things we can see. Then just after getting the equation, just wash through your eyes whether it's looking nice. Okay, whether the scatter is very imbalanced, that you have to see, that I will show you. Okay. So I will just send you the, I will just, can you send through, can you send through the chat possible? How to attach screenshot file. Okay. I am sending you the file. Okay. Okay, I think it is giving the error that it is in currently use.
So you can share it on our WhatsApp group directly. We can all get it.
Okay.
Yeah, you might have to close it before you share it on Zoom, I guess.
Just I will.
Okay.
Yeah.
Because in a way, Zoom might be useful because I can immediately download if you have to do any work on it. On
So
the
I
laptop.
just I sent. I'm sending on the our Zoom meeting. Okay, it just download immediately. Otherwise, we'll lose this.
Yep, got it.
You download now on your PC. So I'll close the PPT. Stop sharing. Open the file. Test one.
Download it, sir.
Yeah. So are you able to see the Excel? It is not showing. I will again one more time share. You just open this. I forgot to mention one thing that while doing this exercise, you do on the PC and use the mobile for understanding. Okay. If you have PC, you can download. Okay. I'll make the size of data little big instead of 80. Can you see the data now?
Yes, sir.
Okay. Now what you need to do, you to pick the data, all the data. Okay. Pick. Okay, you have picked the data, then you go to the insert. Pick the data, then go to insert. In insert, you will find many options. Go to the scattered. You'll find many options in the insert. You go to the scattered. Okay. In the scattered, you select only markers. It's only points. Okay. In the scatter, only select the points. Okay. You click now. Scatter with only markers. Okay. So if you do that, you'll able to see the points here. Okay. You'll able to see the points here. Now, before going to this relationship, we need to understand one important thing. What is independent and dependent parameter? Okay. So can anyone tell me in the X and Y, what is the dependent and independent parameter? Before that, I will just go to the chart and display the variables. Okay, so just go to this chart layouts, click the charts layout. Okay, so that it can show you. Okay, X and Y, it can show.
Please show once again charts layout.
Okay, just I will go back.
Okay.
Okay, here there are charts layout. Okay, so what type of I want here both the options. Okay, just click here. So it will also give the axis title. We can change here. What is this axis? On the X, this horizontal axis is what? X. Okay. So we give the value. X is maybe some here. We can say body age here. Okay. Just give the one example. X is the age. And Y is Y. You just click here. So you can type here. Y is what? Weight. Okay. Just simple, some data I have taken, not actual data of age and weight. Okay. Before going here, I just mention you what is meant by independent parameter and dependent parameter. Okay. Independent parameter means what? It will not depend on anything. Okay. Like the age of the person. but the weight, which is a dependent parameter, it will depend on what? Weight. It will depend on what? Age. So age is independent parameter and weight is what? Dependent parameter. Understood? So X is what? Independent parameter and Y is always what? Dependent parameter. Okay. So we write the equation Y is we write. Okay. So Y depends on what? X. So Y is what? Dependent parameter. X is what? Independent parameter. Okay. So we have plotted the values. Okay. Simply, I will just again repeat. I'll just delete for a moment. Okay. Just select the data, including the headline. Go to the, just I think some chart comments are there. Whether any question. Okay, so this is my Windows 7. So maybe it will have different options. Okay. So you click this, more or less the other version also, it will be similar. You go insert, then you go, there are the line, and there is scatter. This is scatter plot, please understand. We don't want the line because this is not equation line. Okay, this is just, this is what just line made by joining the points. Okay. Okay, so you select without the line. So we say scatter with only markers. So you got this. Scatter with the markers. So this is whenever graph is there, horizontal is what? Independent parameter, and vertical is what? Dependent parameter. Okay. Okay. Now you click any point and right click on the mouse. Right click on the mouse or right click on the buttons of the laptop. Okay. Right click. Then you say there are different options. Delete. You can delete the data. I deleted. Again, go back. Don't worry. Right click again. Then you can also change the data type. Select the data if accidentally you have selected some different data. Then what we have to do is add trend line. Please understand, add trend line gives the equation of that line. Okay, so we can add different lines. Okay, so I will just say add trend line. Once you go to the add trend line, it will ask you the different relations. It will ask different relation. Please understand, it is not suggesting you any equation. It is just telling you to choose what we want. Okay. Like we will start with the linear. So I have just selected linear. Okay. And then we have to tell the software that also display the equation. Okay. Are you able to see the equation now? If I display the equation, it has displayed the equation. I will again go, right click the data, add trend line. Before adding the trend line, what I do? I delete the old trend line. Okay. So that it will not, I will not get confused. So go to the data, right click the data, add trend line. So here you will say different types of the relationship between the data: exponential, linear, logarithmic, polynomial, power, moving average. So we'll start with the linear. Please understand. what we'll do, we'll plot all the equations, okay, and then decide which relation is better, okay. So I will tell software to display the equation as well as one parameter that is called as R square value, okay. Larger the R square value, better is the relationship. Larger the value of R square, better is the relationship. So first thing I did, I have chosen a linear relationship. I got the value of R square as well as the equation of y. Okay, understood? Understood? So this is what? Linear. Okay. So I'll just make one table here where I have to select the base relation. Relation, then R square value. What is criteria? Your R square value should be higher as well as the line should properly pass through the points. So linear, how much is the R square value? So I will just write here. You can see here R square value for this relation 0.949. Okay. So we have to again move. We have to do for all the possible relations. Okay. So how we find this fitting? If you visually see, I feel little bit okay. It is mostly passing through all the points, and scatter seems to be the balance. Okay. What I'll do, I'll move this away so that I can take one more graph. Okay. Now you again select the data. Okay. You again select the data. Go to the insert. Go to the scatter. Select scatter with markers. Now what we'll do? We will not take now.
Take a next point.
Yeah, linear. We will not take linear, but we'll take other. That is like exponential. Okay. Even you can say the exponential. It is very much passing through all the points. Okay. Then I will tell the software to display the equation, display the R square. Okay. So visually it is very much comfortable. You can see it is going through all the points, and the value of R square. R square value tells if it is a 1 means exact fit, and it is very close to 1, 9.999. Okay, so it is what? Which one? Exponential. This is a relation. Okay, you can see here 53.31 e raised to 0.813x. Okay, exponential relation. It feels, I feel it is better, but we should not be in hurry, okay, to take the decision. So you follow all the fittings and then you decide which one you want to take, okay. No need to make hurry, okay. So we have fitted linear. In the linear, R square value was 0.949. And fit was not exact, but if you say exponential is almost passing through all the points, okay. And fit is 0.999, means almost close to 1, okay. The ideal value of R square is what? 1. But what we have to do, we have to select the highest value, okay. So that relation is a base relation. Again, go for this, you go for plotting the graph, go to the scattered, and then scatter with only markers. Okay. Now take the third option, that is add trend line. Now what we'll do? We'll take the third one, logarithmic. You tell the display equation, then display the R square value. Now you can see the visually, even if you see visually, no, it is not passing through the points, okay. And the value of R square is very less, okay. So it was logarithmic value of 0.792, which is very less. So it is not, we can say, recommended relationship. Okay. Neither the line is passing through majority of points. So on, we have to do this. Till this time, only the exponential is better. It seems to be better. Okay. So we'll go further. We have to try to fit as much as possible the type of relations. Okay. This is very important when we go for new relationship between the different parameter. Either the parameter is new or the phenomenon is new. Okay. Now you insert scatter. Okay. So right click, add trend line. Now we'll take the polynomial. Okay. Polynomial, it is also looking nice. Okay, but not as exponential. Okay. So here also the R square value is 0.9, means it is also good. Poly 2. Okay. So R square value is 0.999. Okay. So we have there is tie between polynomial 2 and exponential. Okay. Just go to the curve. Now one more relation we'll try. I will select again the data points. Then insert, scatter. So we'll try last one. Add trend line. Then power will take. Then tell to display the equation. So the fit is not that much, you can say, comfortable, because the spreads not seeming to be symmetric. Okay. And R square value is not that much good. Okay. So this was, what is the name of this relation? Power. Okay. So friends, now we have set 5 relations. Okay. And as per guideline, R square value should be what? Maximum. Okay. Ideally it should be 1, but it rarely happens that R square value will be 1. Okay. So what we have to select is the best one. Can anyone tell which is the best one here? Can you see this?
Exponential one.
Yeah, there are two.
999.
Poly also.
Yeah,
Both.
both are there. So in the tie case, we have to visually observe again. Okay, so we'll just visually observe. First one is exponential. Where is exponential? This is exponential. You can see here, it is almost passing through all the points. Okay, and next one is what? Exponential and poly 2. You'll see the poly 2. Poly 2 is also similar. Okay. But if you see the equation of Pauli, I'll just make it bigger. How many terms it is having? 1, 2, and 3. Okay. So there are 3 terms, but in exponential, how many terms are there? Only, we can say 1 term. Okay. So in Thai case, both are having the R square same. So we'll say take the smallest equation. So that is this equation. Okay. So we'll choose this as our solution. Okay. So we got the equation. What is that? I'll just make it soon. Okay, this will be our final equation. Okay. Got. This will be our final equation. What is that equation? Y is equals to 53.31 e raised to 0.813x. Okay. So we got the relationship from our reading. This is our reading. So can anyone conclude what is the relation between x and y? Now, what was our purpose of research? To find the relationship, to find the equation and type of relation. What is the relation is now? Can anyone tell? What is the type of relationship? Can anyone tell? Type of relationship? Yes?
Exponential.
Yeah, it is an exponential. It is an exponential. Do you know how bacteria grows? What is the relationship of its growth?
Exponentially.
Yeah, it is exponential. Means it become 1 to 4. Means 2 square, it exponentially it will be exponential. Okay. So it will go on growing. Okay. So it is suddenly it will shoot. Okay. So all of a sudden the person will feel illness. Okay. In a later stage, it will be very high. Okay. It is exponential. So this way, we find the relation among the parameter based on the data. Here, the number of data points are how much there? 1, 2, 3, 4, 5, 6. A very small number of data. It is not that much good that you make the relationship based on the 5 points. Okay. You need to make very huge data. Okay. So that the accuracy of your relationship is good. Okay. Understood? You understood the method?
Yes.
Yeah. Okay. So this way we find the relationship among the parameters. So only what we need is the data, and we have to use the Excel. So whatever I shown in the PPT, all that mathematics not coming. Directly we get the equation. Okay. That is the fun of this Microsoft Excel. Okay. Is it clear? Now I will just move to the PPT again. Stop sharing. Well, I can move to the PPT. So we got this equation, and this equation, what we are doing, the Excel itself is doing the finding this value of A and B and directly giving it as the doing all this calculation and directly giving us the value of A and B. Okay. As well as it is calculating the R square value. Okay. Now what happens? Originally we solved this equation for straight line. And when the relation becomes different, like here, can anyone tell what is this type of relationship here? Can anyone tell me the type of relationship here?
Exponential.
It is an exponential. Okay. Now, when we want to match the data, better that you convert your x and y axis so that it will look like as a straight line. Okay. The same philosophy, it follows least square method for converting the different relationship. Okay. So suppose I want to see this relationship on the graph as a straight line. Okay. So what I have to do is I have to take on x-axis x as it is, and y-axis we have to take what? Log of y. And then you plot the line. Line will become what? It will become straight, and the data point should appear across this. Okay. Then the visualizations is better. Okay. Now what happened? We found the relationship here, which is the exponential. Okay. Just example we saw in the Excel. The relationship was Excel, and we just saw the data points along the lines only, but that is not correct method. What correct method is that we have to plot this on the semi-log graph, and then we have to see the straight line and how the data points are spread across it. Okay. So we'll just see that. Okay. We'll go again to the graph. Again, go to the graph. Can you see the graph?
No, sir.
Yeah. So what I will do now, x is as it is, and log what I have to do is capital Y will be ln of y.
Sir, we cannot see the graph.
Cannot see. So, sure.
Yes, sir.
Now what I did, x as it is, I will take. Okay. So I will do equal this. Same will come. You just drag now. All column will come as it is. How I did, I will again explain it. This column is equals to x equals to what? I will just click his. You first put the equal sign. Put the equal sign. Put the equal sign, then click x, then enter. You just drag this. All the points will come as it is. Okay. Why I'm doing? Because for y, I have to take the logarithm of this. Okay. So in the y, what I have to do? Equal. Then you put ln. Can anyone tell me what is meant by ln? ln is a natural logarithm. Okay. ln is a natural logarithm. Then you select this. So this column is what? Natural logarithm of this column. Okay. Enter. Okay. Now you just drag this. Okay. By doing this, what will happen now? I have to fit not now exponential, but I have to fit what? Straight line. Okay. Please understand it. So I'll just put it at capital Y. Insert. Add trend line. What I'll put now? Linear. What was my purpose here? To properly visualize the spread of the data. In the curved line, it is not very much clear, the spread of the data, but in the straight line, it is clear. Now you can see that almost the data is along the line. Okay. Although it is a seems to be straight line, but what we have done is we have converted data and then obtained this. Okay. Are you getting my point? Little difficult to understand. It is for visualization. This step is for what? This final step is for visualization. Okay. Because in curve case, we cannot see the spread of the data very clearly. But after converting data and fitting the straight line, we can see the spread. Now we can see that almost all points are on the line. Almost all points are on the line. You're getting this last point that in PPT. Okay. Okay. I will just again repeating this. Don't worry. Okay. I will repeat both the step. Okay. So you will not get confused. Okay. First, select the original one. Select the original data. Go to insert. Go to scatter. Okay. This is the original data. Okay. Then you fit all the relations. Okay. All relations you fit, 5 relations. Then you decided to go for exponential relation. Okay. So that relationship I will put here. Okay. Okay, we got this relation, no problem. Okay, we got this relation, we accepted this relation. But only one doubt remain in our mind, that whether the spread what I am seeing, either here the curve is there is curvature on the line. Okay, so seeing the distribution of point along the line is difficult. Okay, here the points are very much matching because I have generated that from the equation only. Okay, that's why you see this measure of the points are what matching to the lines. Okay. But here one doubt remains in our mind whether on the curve line, what I'm seeing, they are very close to the line, whether it's correct or not. To cross verify the distribution, what you do? Now we know the exponential relation to obtain the straight line. For exponential relation, obtaining the straight line, what we have to do is we have to keep x as it is and you have to take the logarithm of the y. So I have taken the logarithm here. Okay. Now my next purpose, I was just selected this relation, but still confusion remains whether the spread of the points along the lines is good or not. So now I have taken x as it is, but instead of y, I have taken what? Logarithm of y. So I will again go and then insert. Okay. Okay. Now when I converted for exponential, that I will send you the PPT. It will tell what is to be converted. Okay. It will tell you what is to be converted. For exponential relation, we have to convert what? Y. From y to logarithmic y. Y to logarithmic y. Now you put the, after converting, we have to only plot the straight line to see whether the distribution along that line is okay or not. Okay. Plot the R square. Here relation is not important because we don't want relation. We want to just see, observe the spread of the data point. So it is data point spread is very good across the line. So we can select this relation. Which relation we have to select? This one. Y is equals to 53.31 e raised to this. Okay. This relation we have selected. Okay. We got confidence relation is correct. Okay. So what I will do now, I will send you one more exercise. You complete me and then send like this. Okay.
So please show once again how you got the logarithm of the
Yes, yes.
7100.
Yes. Yes, please repeat question.
So how did you copy the x and get the logarithm?
Okay. So you understood the first step. We have to take data as it is. Okay. Data as it is. From data you plot 5 relations. Okay. After 5 relations, we have to choose the best one. So we have to choose the best one is the exponential. Okay. So in this line, if you see, it is curved line. Okay. And on the curved line, the spread of data visualization is not very, we can say correct. Okay. Because it is an exponential relation. Okay. So see on the straight line, what we have to do is, here we are, please understand, we have selected this relation. Still one doubt is there in our mind whether the spread of the points along the line is okay or not. Okay. For that, what we have done, for exponential, there is a guideline. I will show you the PPT. For exponential, what we have to do is keep x as it is. And for y, what do you do? For y, you convert to the capital Y, that is ln of y. Okay. I did that. Okay. And made this column. I again made the x column and I again made the y column. But y is now what? Y is now ln of previous y. Now I
Can you show please?
will just make it big. Please understand, now we have selected this one relation. Okay. What happens? This is the exponential relation. So the how should be the spread of the points. Okay. Maybe here it can be closer, it can be far away. So it will not giving the real sense of spread. Okay. On this curve. Okay. Other than straight line, what happens? The spread of the points. Okay. All across this line may not be visually correct. Okay. So in that case, we have to visually cross check whether the spread of the points is good or not. Okay. In that case, there is a guideline for exponential relation. What we have to do is we have to convert x to the x, y to the ln of y. And then again, we have to plot the graph. But we have to plot the graph as what? Straight line. Please understand. We have to plot the graph as what? Straight line.
Sir,
Yes.
we understood that. We just wanted you to show us how to get this data, how to get ln of y. You just showed it at the first time.
Yeah. I will.
75 ka. Only
Yeah.
that much we.
Okay. Here you go. First you put equal sign. Okay. Then you write ln. ln means what? Natural logarithm. Then round bracket. Then you select that value. Closing round bracket. Then you enter. Okay. After that, what you do? You have to drag this. You drag this. You'll get this. Okay. Okay, after plotting this straight line, you see the spread of the points across the line. It is very much good, okay? Or you can say equal, okay?
Thank you, sir.
So our verification is correct and we are firm that this is our final relation, okay? So I will send you 1 or 2 assignments on this. I'll send you the data. You find the base relation like this, okay? Okay, I will send you. So if you any doubt on today's session, today's session is any doubt? I will share the PPT
No,
also.
sir.
No,
Okay.
So I have a question,
Yes.
Professor.
Yeah.
So I understood for exponential you have to take the natural log, and I can guess why. But
Yeah.
what kind of changes will I need to do if I'm representing any of the other
Yeah,
equations?
that
Like-
I will show you in 2 minutes. Just I will show you. Just I'm sharing you. First exponential I've shown you. Okay. This is the exponential. Then we have to take y as what? Log of y. Okay. Then plot the straight line.
log y, because
and
it's
then-
e raised to x.
Then visually see the data for the straight line. The straight line is not your solution. It is only for visualization. Okay. Then come power. For the power, what we have to do? We have to take log. For power, we have to take log on x-axis and log on the y-axis. Okay. For the power. Power means
Okay.
what? X raised to p. Okay. That is the power. Then I will just clear this. Then this is what? Polynomial of 2. You have to see polynomial order is what? This power. Polynomial of 1 means what? Here becomes linear, what is called as linear equation. Okay. Polynomial of 2. So here they have given the criteria. So here will be x will be x, and y will be y minus y1, and divided by x minus x. Like this.
Previous one or next one.
Yes, what? This is
So
what?
y minus y1 equal to what? Y, matlab data point,
This is
previous
the-
data
this
point
is-
or the next data point?
This is a y. This is a verification. We can say verification where we want to plot the straight line. Okay. Are you getting the point? So last step, what I showed in the exponential, I
No, sir, I
plotted.
understood that. I was
Mhm.
asking when you say, so if the data points are y1, y2, y3, I'm asking if y minus
no.
y1 means
Suppose-
y2 minus
yeah,
y1 or
yeah,
y1
yeah.
minus y2.
Just please understand. Suppose your relationship you fitted is a polynomial in the 2. Okay.
Yeah.
In that case, x will be x, no change.
Yeah.
Y will be y minus y1 divided by x minus x1. Okay. That column you have to make like that. Okay. Are you getting this?
Okay, let me ask this on our data. I'm saying that is it like in the data test one that data is y is any given point, is it 100 minus 75 or is it 75 minus 100?
Please,
Or does it
yeah. Yeah, please understand what is the meaning of here. Y1. Y1 is what? Y1 is this. Y1 is calculated as B1 plus C1 X1, where it is cutting the
okay.
line. And
Intercept. It's intercept. Okay.
This is Y1 and this is the X1. So we
Okay.
have to subtract every time.
Okay. On every data point, you have to subtract the intercept. Okay.
Yeah, that is maybe difficult. I have not done this. But maybe
Yeah.
little.
No, I was just not understanding
Yeah.
notations. That's why I was asking.
Little difficult, but
Yeah.
I have
Okay.
not done this. This is the polynomial 2. Okay. Then method to how to find the R square value. This is mathematical method, okay, but we have not kept for you. This is just for your information. Okay. R square value should be ideally should be 1, but it not happening, so we have to take close to 1. Okay. So one book you can refer, that is Hallman. Hallman is basically what it is for engineers, okay? Experimental methods for engineering. Basically for engineers. Okay? When you do for experiments, it is good book for you can say research scholar, PhD student. Okay. If you want, I have the copy. I have hard copy, so difficult. But if you want, I can give you for Xeroxing. Okay. So this is all for today. If you have any doubt, you can ask me. Or then otherwise you can stop here. Is there any doubt? So I will send you the, I think I have not added in your group. So I will just send you one example now only. Data points. So I just send you the data points. Just copy this. Not in Excel, just pasted the data. Try this and find the basic relationship. Okay, thank you. So I'll stop here. Thank you.